Good. Here's the problem 6.39. We're given the velocity potential phi, a half x squared minus y squared, and we're asked to find the corresponding stream function. So we're first going to find the velocity components and then use them to find the stream functions. So u velocity is delta phi per delta x, which is in this case ax. Similarly, v is delta phi per delta y. Remember, with potential phi, both are positive derivatives. For stream function, u is delta psi per delta y, and v is minus delta psi per delta x. So here we have basically minus 2ay for the v component. Now, delta psi per delta y is equal to u, velocity is equal ax. But also, so from that, we're directly, okay, this is error. From that, we directly integrate and get phi, psi equals integral of ax dy equals axy plus generally a constant, but this is only constant with respect to y. So we'll assume that it's some kind of function that can only be a function of x and not of y. Now, we say that delta psi per delta x is equal minus v equals, because v itself is minus 2ay, sorry, it's not 2ay, it's minus ay. So minus v is just ay. But at the same time, from this function itself, I can find that same derivative, delta psi per delta x, and with respect to x, so this is ay, plus some derivative of this function per x. Now essentially I have this and equal to this, so I can write, we can see immediately that f prime is 0, but let's write it long way. So f prime of x is equal ay minus ay equals 0, which means that function f of x itself is some true now constant c. And finally, the whole stream function is basically a combination of the two, so we have axy here plus c. And the question now, given that this is arbitrary, we can just assume or set c to 0 for the illustration purposes. We want to sketch the function itself. So we can essentially say that this function in general is, we can absorb this in some other constant. We can just say that this function represents xy equals constant. So we're looking for the family of curves that satisfies this. And for constant equals 0, we'll have x equals 0, and we have two solutions, and y equals 0. In other words, the coordinate axes themselves are the streamlines of this flow. So we have here and also here. Now, for other values, we'll basically have the situation that u equals constant over x, and you will probably recognize that this is the family of hyperbolas. So essentially, in all four corners, given that this constant can be positive or negative, that y can be positive or negative, x can be positive or negative, we essentially have a family of hyperbola in all four. Of course, my drawing here is not the best, but I guess I get the message across. Now, if we want to determine the direction of this flow, if we assume that A here is positive, then we'll have positive, we're looking at u velocity, u is equal ax, so for positive A, we have, I'll put here directions for positive A. In this case, u velocity will be positive here and will be negative here. V velocity, on the contrary, will be negative for positive u, so it will go like this, and will be positive for the negative u, so it will go like this. Obviously, all the velocities, the velocity magnitude at 0 is going to be 0. That's the only way that two streamlines can cross, if the velocity at the crossing point is 0. Once we have this, it's then easy to just expand those directions to other streamlines. And that's the solution.